Welcome back to Vuln Vibes. In this deep dive, we're going to talk about the Geutebruck G-Cam vulnerability. We're tackling a pretty critical architectural flaw, really highlights the dangers in some of these embedded systems. For the pros tuning in, you know we like to get right into the core exploit details. Today, it's all about this really cunning method for getting unauthenticated access and against physical security gear, no less.
Yeah, and if you haven't already started looking at these assets, isolating them, patching, well, you need to be moving fast. We're talking about a vulnerability that hit 9.8 on CVSS, critical.
9.8, unauthenticated SQL injection. That's about as bad as it gets, right?
Pretty much, especially when you think about perimeter security hardware being the entry point.
Yeah.
The implications are significant.
Absolutely. Zero credentials needed means, well, the door's wide open. But it's not just the score, is it? It's the how, the technique involved. Our mission today is really to unpack that specific kind of multi-layered technique. The way they manipulated URL-encoded XML CDATA blocks, that's the really interesting part for folks like us.
It really is quite sophisticated. This isn't your garden variety SQL from, just bad string handling. It plays on a fundamental misunderstanding, really, of how different processing stages handle data context. It lets the payload slip right past common defenses. Understanding this evasion is key, especially when the vendor's quiet.
Okay, let's set the scene first. What's the blast radius look like? What are we dealing with in terms of hardware?
We're focused squarely on the Geutebruck G-Cam E-Series line. You see these cameras everywhere, industrial sites, corporate buildings, places where surveillance is, mission critical.
Right, standard enterprise stuff. And the entry point. Where's the hole?
It's a script.
Yeah.
uapi-cgi viewer Param.cgi. Handles configuration stuff, and the specific weak point is the Groupparameter within that script.
Gotcha. So Param.cgi, Groupparameter. Was there a specific camera model confirmed?
Yes, the initial discovery nailed it on the EFD2130 model. And importantly, it was running firmware version 1.1.0.19. That was the latest version at the time.
Ouch. So a 0 day, effectively, for anyone keeping up with patches.
Exactly. That's immediate exposure right there.
And the problem gets bigger, right?
All right.
The sources mentioned testing on other models.
They did. And crucially, they found various other G-Cam E-Series cameras were vulnerable. And not just vulnerable, but vulnerable to the exact same exploit.
Okay, that sounds like a shared code base issue then.
That's the strong implication.
Yeah.
If the same exploit works across different models, different firmwares, you have to suspect a common core component, which means the working assumption has to be that the entire G-Cam E-Series line could be affected.
Which massively changes the risk calculation for anyone using these.
Absolutely. It goes from maybe one vulnerable device to potentially your whole fleet.
And then there's the vendor issue. The researchers couldn't get confirmation from Geutebruck.
Correct. They mentioned specifically not being able to confirm the full scope because of, no contact, lack of response.
Right. And that really puts security teams in a bind, doesn't it?
Completely. A 9.8 critical vuln on perimeter hardware, and the vendor's silent. You're operating blind. You can't wait for official patches. You're forced into immediate, often costly mitigation, isolation, maybe even decommissioning. That silence, that information gap, it just elevates the operational challenge significantly.
Okay, let's dive into the technical side then. This CDATA evasion tactic. It's clever. First off, maybe just briefly explain what a CDATA block is in XML. Why would a developer even use it?
Well, the intention behind CDATA is usually innocent enough. It stands for character data. Its job is basically to tell the XML parser, look, everything between these markers, .CDATA, and is just raw text. Don't try to interpret things like angle brackets or ampersands as XML markup. Developers use it to embed data that might otherwise break the XML structure.
Okay, so the developer putting user input for the Groupparameter inside CDATA, they probably thought they were making it safer, right? Like preventing XML injection issues by telling the parser, just treat this whole chunk as plain text.
Exactly that. They're effectively outsourcing the sanitization to the XML parser's CDATA handling. But here's the fatal flaw. It's about the order of operations, the sequence. The attacker crafts a payload, the malicious SQL query, wraps it inside a CDATA block, and then URL encodes the whole thing.
Okay, hold on. Let me play devil's advocate here, because this is where it gets tricky. If it's URL encoded, the web server decodes that first,
Yep, standard stuff.
But then the application gets the decoded string, which includes the CDATA block and the SQL payload inside it. Wouldn't the XML parser see the special characters, like the single, quote, needed for SQL injection, inside that CDATA and maybe flag it or error out?
See, that's the brilliant or rather devious part,
Yeah.
and why the sequence matters. Yes, the URL decoding happens. The application gets the XML string. The XML parser starts processing. It sees the outer XML structure, maybe group, then it hits CDATA. At that point, the parser's rule is, okay, everything is raw character data. Pass it through as is.
Wow.
It doesn't inspect or escape anything inside the CDATA block itself. That's the whole point of CDATA.
So the CDATA wrapper effectively acts like a shield. It hides the malicious payload, including the crucial single quote from the XML parser's scrutiny.
Precisely. The XML parser does its job correctly according to XML rules, but that job involves not touching the content inside CDATA. So that single quote, the character needed to break out of the intended SQL query string.
Sails right through the XML layer untouched.
Exactly. It lands perfectly preserved, unescaped, right where the application concatenates it into the SQL query string. The database engine then sees a malicious command or whatever the payload is, injection complete.
Wow, okay. So it's a failure of context handling between layers. The app trusts the XML layer to sanitize, but the attacker uses an XML feature, CDATA, specifically designed to prevent that layer from sanitizing the critical part of the input.
That's it in a nutshell. You could call it parser confusion or maybe multi-layer sanitization bypasses. The XML layer does its job, the SQL layer does its job, but the interaction between them, mediated by CDATA, creates the opening. The database never even knows there was an XML wrapper involved. It just gets the final tainted string.
And with a 9.8 score, we have to assume this isn't just data exfil, right? This likely leads to remote code execution.
That's the necessary assumption for risk modeling, absolutely. An unauthenticated critical SQL on a network device. You have to plan for the possibility, even probability, that an attacker can pivot from SQL execution to OS command execution. Stat queries, database functions, calling system commands, however they do it.
Turning that camera into a foothold on the internal network.
Yep.
A beachhead.
Exactly. It stops being just a camera and becomes an entry point.
Which brings us back to the mitigation headache. If you've got these E-Series cameras, vendors not talking, what's the playbook?
You have to assume compromise is possible and easy. Immediate action is needed. Since patching isn't a reliable, immediate option without vendor support, it comes down to isolation. Either strict network segmentation firewalls allowing only essential traffic, maybe only from specific management IPs, or taking them offline. Physically decommissioning them is the extreme but sometimes necessary step if isolation isn't feasible or reliable enough. You can't afford to wait on a 9.8 unauth RCE.
And the effort involved is just asymmetric. The attacker sends a single crafted HTTP request. The defender might have to orchestrate firewall changes across dozens of sites or physically replace hundreds of cameras. The cost difference is huge.
It really is. And the core lesson here, beyond just patch your stuff, is about understanding these data pipelines, relying on one processing layer, like XML parsing with CDATA, to handle sanitization for a completely different layer, like SQL execution. That's where the architectural risk lies.
Right. So the big takeaway for our listeners, the lesson from this Geutebruck flaw, it's about mapping how data actually flows and transforms. From the initial request, URL decoding, any wrapper formats like XML or JSON, right down to the final interpreter like the database. If you use something like CDATA that tells one layer, hands off this data, you must ensure the next layer is ready to handle that raw, potentially malicious input.
Yes. The validation has to happen at the right point, probably right before it hits the database, after all the decoding and unwrapping has occurred. Not before.
Okay, so let's recap the essentials. We've got an unauthenticated 9.8 CVSS SQL injection vulnerability in Geutebruck G-Cam E-Series cameras. The vector is the Groupparameter in uapi-cgi or Param.cgi. And the key technical insight is the clever use of a URL-encoded XML CDATA block. This technique shields the malicious SQL payload, specifically the single quote from the XML parser,
allowing it to pass through untouched and break the SQL query, leading to potential RCE. The genius wasn't finding in SQL, maybe, but finding how to deliver the payload past the defenses.
Which leaves us with a final thought for you, the listener, to chew on. Think about your own systems. Do you have architectures where input data gets wrapped? Maybe in CDATA, maybe base 64 encoded, maybe inside a JSON object. And then that wrapped data gets passed along to something else that interprets it. A database, a shell, another API. Ask yourself, where does your input validation actually happen? Is it happening before the unwrapping, relying on the wrapper itself for safety? Or is it happening after the unwrapping, right before that final interpreter sees the raw data?
Because if it's the former, you might just have a hidden 9.8 lurking in there,
Yeah.
waiting for someone to find that context switch vulnerability. Shifting that validation checkpoint could be critical.
Definitely something to consider in your next security review. Thanks for joining us for this deep dive into the Geutebruck G-Cam flaw. Stay safe out there, and we'll catch you on the next Vuln Vibes.